Welcome to New Findings of the Universe. Today we are going to follow a signal that travels through the void and somehow finds its way back home. Voyager 1, the farthest human-made object ever sent into space, is sending usable information to Earth again, after engineers solved a computer problem from an almost unimaginable distance. That sounds like a simple update, but it is actually a scene with weight. A whisper returning from a place where the sun no longer rules the sky the way it does here. Voyager is not just a spacecraft. It is a living archive of our cosmic neighborhood, and it is also a messenger that carries a bigger idea, that human curiosity does not stop at the last orbit. In this video, we are going to connect two powerful threads: the return of communication and the last images Voyager ever took before its cameras were shut down forever. Images that became a family portrait of the solar system. A view from the outside looking in. Like someone leaving home for good and turning around one final time to see the house become a line of tiny lights. That portrait is not a perfect postcard. It is something more honest. It is what a camera built for close-ups of giant planets could do when asked to attempt something almost poetic. To look back and capture faint worlds lost in the glare of the sun, and at the emotional center of it all is one tiny point. The pale blue dot, Earth, suspended in a beam of sunlight. Not because of detail, but because of what it represents. Everything we have ever been happened inside that pixel. Stay with me, because we are going to travel across every world in that portrait and then push beyond the edge into interstellar space, where Voyager still moves forward. If you love astronomy told as true story, subscribe now to New Findings of the Universe, and let's begin. Picture a spacecraft launched in the 1970s, built with computers weaker than any phone today, and yet it is still alive, still speaking. Still sending data through a radio thread that grows thinner every year. Voyager 1 is so far away that distance stops being intuitive. We are talking billions of miles, billions of kilometers, a region where sunlight no longer feels like daytime, but more like a bright star in a dark sky. And still, Earth receives its signal, exhausted, faint, but real. Now, long ago, that conversation broke. The data arriving at Earth was corrupted, as if Voyager's language had become scrambled. And here is where the story becomes almost unbelievable. Engineers on Earth diagnosed the failure to a specific computer component inside a spacecraft more than 15 billion miles away, beyond Pluto, outside the solar system, drifting in the space between stars. It is like repairing a watch from across an ocean, using only the sound of the ticking. They did it by sending commands, rerouting functions, and finding alternate pathways inside an aging system designed for another era. When Voyager began returning usable information again, it was not just a technical win, it was proof of human patience. Voyager is not immortal. Its power declines year by year. Instruments are shut down one by one to save energy. Every system kept alive is a choice. That is why the return of communication matters. It means we still have an active messenger at the edge of our solar home, measuring the interstellar environment and sending readings no other human object can send from that position. And at the same time, this news makes us look backward, the way Voyager once did. Because before it crossed that threshold, before distance and power demands forced cameras to go silent, Voyager left us a gift. A set of final images, a portrait of the solar system from the outside. Today, we are going to open that gift and understand why those photographs, even if they look simple, are among the most powerful statements astronomy has ever received. This pulls you in? Subscribe. Because on this channel, we turn distant data into close human meaning. The solar system family portrait was not an automatic idea. Voyager was designed to fly close to giant planets and deliver detailed views. Its cameras were built for storms, rings, moons, and sharp features, not for tiny points of light near the sun's glare. Looking back was almost a technical rebellion because the spacecraft was never meant to become a farewell photographer. But someone proposed something bold to capture the solar system from outside, as if the universe itself could hand us a mirror. And that proposal created a moment that is both scientific and emotional. Doing it was extremely hard. At that distance, the planets spread across a huge arc of sky, and many of them are faint. The sun is not just bright, it is blinding, and light inside the camera can scatter and wash out the image. Reflections can appear, glare can create streaks, and entire worlds can vanish. Still, it was worth attempting. It was a once-in-a-lifetime opportunity because Voyager's cameras could not stay powered forever. And no other spacecraft has repeated that exact position with cameras active. So, the decision was made. The cameras were turned on, warmed up, and the spacecraft began a slow sweep, capturing image after image, rotating its narrow-angle and wide-angle views to record the positions of the visible planets. Instead of a single photograph, it became a set of frames that would later be stitched into a mosaic. That mosaic became the family portrait. When you look at it, you see dots, smudges, small lights. But each one is a world. Some appear clearly, others barely, and some do not appear at all. That, too, is part of the truth. The solar system is not a display case designed for a perfect photo. It is a place of glare, shadows, and instrument limits. The greatness of the portrait is what it suggests. We live inside this home, and for the first time we saw it as a whole, not as a map, but as a presence. In the next moments, we are going to travel through that portrait planet by planet. And we are going to see why the missing worlds are just as meaningful as the visible ones. As we move through the portrait, the first surprise is that the planets do not look like detailed globes. They look like signals. Venus appears as a soft pale crescent because its global cloud deck reflects sunlight in a gentle way. Earth appears as a tiny pale blue pixel, almost nothing, and yet it carries the most emotional weight. Jupiter and Saturn stand out as brighter points because they are large and reflective and still able to push through the background. Uranus and Neptune appear as faint bluish smudges, ghost-like, near the edge of visibility. And the Sun itself looks different than you expect, not like a blazing disk, but like a bright, spiky star created by diffraction and internal optics. A reminder that every instrument leaves its own fingerprint on light. And then there are the planets that are missing. Mars does not appear in the mosaic, not because it was not there, but because scattered sunlight inside the optics washed it out. Mercury suffered a similar fate, too close to the sun's glare to be imaged cleanly. That is a quiet lesson in astronomy. Observing is not just looking. It is fighting light. Some of the hardest work in space imaging is controlling glare, understanding how light enters, bounces, scatters, and tricks the camera. This portrait is humility in visual form. It was not taken to be perfect. It was taken to exist. To say, here is our family as seen from far away. Here is what is visible. Here is what is lost. Here is the reality of trying to photograph tiny worlds from billions of miles away. And even with all those limitations, the result became iconic because nobody had ever done it. Nobody had ever taken a portrait of the solar system from the outside looking in. But to feel the full power of this mosaic, we cannot stop at dots. We have to remember that Voyager saw some of these worlds up close and changed our understanding forever. So now we are going to step back through the journey toward the encounters that made planets and moons real. Before it became the faraway explorer drifting toward the stars, Voyager passed through giant worlds and turned them into living science. At Jupiter, scientists expected grandeur, but they found complexity. Dynamic cloud bands, layers of storms, a planet that looked alive in motion, and then the moons. Not silent rocks, but active worlds. One moon revealed volcanic activity, towering plumes. A shock that rewrote what we believed about energy far from the sun. Discoveries like that changed planetary science. Then Voyager reached Saturn, and the story became a fork in the road. Saturn was not only rings and beauty, it was a navigation decision. There was a target, a large moon wrapped in thick haze, a place that hinted at chemistry and atmosphere. Flying close to it meant using gravity to redirect Voyager's path. In exploration, every redirect is a destiny. That choice sent Voyager 1 out of the plane of the solar system, shaping its future and ending certain possibilities while opening others. Saturn itself revealed rings as architecture of light, countless fine structures that shift as the sunlight angle changes. It also showed that moons can be laboratories with their own weather-like systems and chemistry, not just companions. Voyager became more than a visitor. It became a storyteller of entire planetary families. In the family portrait, Jupiter and Saturn are only bright pixels. But behind those pixels are thousands of frames, measurements, and moments of discovery. That is the strange beauty of the mosaic. It compresses giant stories into tiny lights. And as Voyager moved farther away, photography became a luxury it could not afford forever. Power became precious. The mission began to shift from seeing to sensing, from images to instruments. But before the cameras went silent, Voyager still had one last act: to look inward and capture the most fragile image of all, home. When Voyager aimed its camera at Earth, it was not chasing detail. It could not. At that distance, Earth is not countenance or clouds. It is a point. The astonishing thing is how much a point can hold. In the final mosaic, Earth appears as a pale blue pixel suspended inside a narrow beam of sunlight. That beam is not magic. It is optics. Light scattered within the camera, and yet the result feels like a message. A whole world trapped inside a line, small, delicate, almost invisible, and yet carrying everything. When you let yourself really look at that pixel, something shifts. Borders vanish. Arguments that feel enormous on the ground shrink when scale expands. Astronomy is scale. It is learning where we are. And that is why this image became famous. Not because it is sharp, but because it forces a truth. Every person who ever lived, every civilization, every moment of human history happened on that dot. There is also something uniquely human about the way this happened. A robotic spacecraft, moving away into darkness, turned back and gave us a mirror. It does not feel emotion, but it delivers a frame that makes us feel. It gives us humility and maybe a little sadness, and also gratitude. Scientifically, the portrait was also a massive observation challenge. A sweep across a broad arc to capture planetary positions and brightness at a specific moment in time. It is a geometric snapshot of our neighborhood, taken from farther than any previous image of its kind. Soon after, the cameras would be shut down to save power for instruments needed to study interstellar space. That decision meant Voyager would never take another photograph again. Every dot in that mosaic represents the last moments the cameras were alive. And with the cameras off, the mission became something even more mysterious. Not in fantasy, but in real physics beyond the solar bubble. Before it became the faraway explorer drifting toward the stars, Voyager passed through giant worlds and turned them into living science. At Jupiter, scientists expected grandeur, but they found complexity. Dynamic cloud bands, layers of storms, a planet that looked alive in motion. And then the moons. Not silent rocks, but active worlds. One moon revealed volcanic activity, towering plumes. A shock that rewrote what we believed about energy far from the sun. Discoveries like that changed planetary science. Then Voyager reached Saturn, and the story became a fork in the road. Saturn was not only rings and beauty, it was a navigation decision. There was a target, a large moon wrapped in thick haze, a place that hinted at chemistry and atmosphere. Flying close to it meant using gravity to redirect Voyager's path. In exploration, every redirect is a destiny. That choice sent Voyager 1 out of the plane of the solar system, shaping its future and ending certain possibilities while opening others. Saturn itself revealed rings as architecture of light, countless fine structures that shift as the sunlight angle changes. It also showed that moons can be laboratories with their own weather-like systems and chemistry, not just companions. Voyager became more than a visitor. It became a storyteller of entire planetary families. In the family portrait, Jupiter and Saturn are only bright pixels. But behind those pixels are thousands of frames, measurements, and moments of discovery. That is the strange beauty of the mosaic. It compresses giant stories into tiny lights. And as Voyager moved farther away, photography became a luxury it could not afford forever. Power became precious. The mission began to shift from seeing to sensing, from images to instruments. But before the cameras went silent, Voyager still had one last act: to look inward and capture the most fragile image of all, home. Voyager keeps drifting outward, and every year its voice grows fainter. But its story keeps growing, because what it represents is larger than the signal itself. The family portrait is an ending and a beginning. An ending because Voyager never took another photo after that mosaic. A beginning because that look back changed how we see ourselves. There is something powerful in realizing the solar system can be reduced to a thin arc of lights, and Earth can be reduced to a pixel. Not to make us feel small in a hopeless way, but to place us accurately in scale. Astronomy does that. It teaches you that home is precious precisely because it is small and vulnerable. And it teaches you that curiosity can push human-made objects across boundaries that used to be only imagination. When we hear that Voyager is sending usable data again, we are hearing a promise. A promise that there are still discoveries at the edge, and that patient work on Earth can keep a connection alive with a spacecraft beyond easy comprehension. That connection will eventually end. One day Voyager will fall silent, not as a defeat, but as the natural finish of a mission that already did the impossible. What remains is the lesson. One spacecraft traveling for decades reshaped maps, revealed worlds, created a family portrait of our planetary home. Reminded us that Earth is a pale blue dot, and pushed us to think beyond our own lifetime. Now I want to hear from you. In the comments, tell me what hits you harder: that Voyager is still speaking from so far away, or that our entire world can fit inside a single pixel. And if you want more stories like this, where science feels close and the universe is treated with respect, subscribe to New Findings of the Universe. Turn on notifications, and I will see you in the next video. Because every signal returning from darkness is a new finding of the universe.